Okay, cool. Hi everyone, my name is Anders KRUS. I'm with VMware and I'm a networking NSX specialist. And this is really an awesome place. I'm not sure how much that is visible in the online streaming version, but we are on the penthouse, the top floor of the National Library in Riga. So I've actually decided that I will start with a selfie, so you can look a little bit happy and a little bit, okay. It's fantastic. Anyway, software-defined networking is not that easy to explain what it is, since it a little bit depends on who you are and who is asking. But from our perspective, we do SDN by overlay, which means that we are building software networks for a software virtualized environment. There are other big companies also doing what they see and call SDN, and which is fine, but SDN is also taking place in the physical network. And just note that those are not two competing approaches, so we can easily run our SDN solution on top of any SDN-defined networking. So we are not trying to virtualize hardware using OpenFlow protocol or separate the controller from the hardware. We are purely making networking within the hypervisor environment. So when VMs, virtual machines, are talking to each other, instead of using the network and leaving the network responsible for all the functionality that VMs may need, we provide that right away in the software. We have a product for this, it's called NSX, and NSX is adding networking components into a virtualized environment. So we bring everything that you normally find in the physical network, such as switching, routing, firewalling, and load balancing, and also going in and out using ciphered connections, VPNs. This is a security convention, so let's talk about security and firewalling in the SDN-ified world, if you can say SDN-ified, then yeah, I hope you understand what I mean. The thing is that the legacy approach of firewalling is that you have the firewall somewhere in your network, and if we look at this picture, to the left we see the legacy data center with the firewall in the middle. This firewall could be virtualized or it could be physical. It doesn't matter, it has a position in the network. So it's a choke point, and it's something that all traffic must pass in order to have security in your virtualized environment. Within a segment, because this firewall, what the firewall has on its hand to work with are segments and IP ranges, IP prefixes. Within such a segment, there is probably no security or very low security. You can close it down using some kind of access list or private VLAN or something like that, but if VMs are supposed to communicate within a segment, then probably you need to lift your security and have no filtering, and if you get an attack or something like that on one of your VMs that you have in, let's say, your DMZ, then that attack may travel further on since it has passed the perimeter firewall. So the fantastic thing about software-defined networking and the firewall that we have in the NSX product that we have for the vSphere environment is not the firewall itself, it's more the position of the firewall. We have added network components into the virtualized environment, into the hypervisor and into vSphere. That means that there is a firewall on every VM instead on every segment. And we call this micro-segmentation or zero trust networking. And one other thing that is a little bit interesting with this approach is that when we group stuff, if you compare to the physical firewall that is grouping by segments, interfaces, and IP addresses, we can actually group on anything. So IP is not our primary tool anymore, because we are building the network and the firewall into the hypervisor, And the hypervisor is the thing that created all the virtual machines. So the hypervisor knows everything. The vCenter, in our case, knows everything about all the VMs that are running in this environment. So we can group and make groups of VMs based on basically anything that is a property within the vCenter, such as the operating system or the machine name or whatever. So this is a screenshot from the GUI. We can create a security group, and we say that this security group is allowed to talk to this security group in this way. And IP doesn't matter. And also, it doesn't matter where this VM is executing. If it's executing in this host, physical host, is it on this host, is it in another data center, or is it even the public cloud? Because what happens when you do SDN by overlay right away into your virtualized environment is that you create the VM and you create the network and the security to this VM, and all of that becomes one entity, kind of. Which means that if the VM moves away from one host to the other host, from my data center to my secondary data center to my disaster recovery data center, or even into the public cloud, it's moved there not only with the compute and the payload, it's moved there including its network and its firewalling. So this means that it's incredibly easy to provide access for virtual machines now, since the virtual machines in a sense are carrying its network with itself. So again, the fantastic thing about the firewall in the NSX product is not the firewall itself, it's where it's placed. It's executing in the kernel of the hypervisor. And we can apply firewalling on each individual VM right away before it's even reaching the first software switch in the host, which is kind of cool. So if you have a number of VMs executing in the same segment, the same broadcast domain, then you can get filtering even still. That is something that is kind of tricky to do in the physical network if you have a physical firewall. So anyway, we have provided switching, routing, load balancing, and firewalling right into the hypervisor. But sometimes you would like to have more advanced security services. The firewall that we are putting into the hypervisor is a stateful, session-based layer 3, layer 4 firewall. And we can do session filtering and session monitoring with this firewall. It's a regular firewall in a sense. But as you know, there are a lot of firewall vendors that are doing higher layer filtering, sometimes referred to as a next generation firewall or a unified threat management firewall or whatever you call it. So can we do that with our firewall? No, we cannot. We are not a security company. But what we did with this product is that we open up a number of APIs for our partners to come partner with us and become a part of this software-defined network. And some of them you see on the screen for security. It's, amongst others, it's a Fortinet, Checkpoint, Trell Micro, Intel, Palo, Symantec, High Trust, Rapid7. And the thing now is that we can let these boys be the same, have the same position as our firewall. Which means that if you have, let's say, a number of virtualized web servers, they are receiving traffic right away from internet. So traffic is coming, it's going towards the VM. We would like to have micro-segmentation in order to get high security, but we also would like to have higher layer scanning, so next generation unified threat, yada yada, firewalling. And when I say next generation, I mean intrusion prevention, antivirus scanning, data leak prevention, application filtering, nested application filtering, yada yada, and stuff that firewall vendors typically put into the firewalls. We can have that in the same way as our firewall, meaning that we can attach the filtering of the traffic right next to the VM. Micro-segmentation, zero trust network, and also sometimes referred to as the network of one. We have a segment that is only one VM, and then comes firewalling. The good thing here is also, now I have Palo Alto as my example, but Palo Alto is only one of the vendors. They were one of the first ones to certify, so I use them as my example. Is that if you invite, being the manager of this environment, if you invite any of these partners, not only can you filter in a micro-segmentation way, what you can also do is in the perimeter firewall, because the perimeter firewall will not go away, you will have a perimeter physical firewall that protects your data center. And you can use the intelligent grouping. Remember that NSX can group the VMs based on any VM property. And then we can say this security group is allowed to talk to this security group, regardless of IP, regardless of where they are. But of course, if we define the security group based on the OS name or operating system or whatever, of course, these VMs in my group here, they have IP addresses. And these groups are grouped on something else, but is containing a group of IP addresses. So in this example, if you are using Palo Alto as my example here, and the panorama management, then of course you will manage your virtual firewall running on each host for the micro-segmentation firewall filtering. But you can also utilize the same groups also in the perimeter firewall, since it's managed from the same security management tool. So here's a screenshot from Palo Alto just showing group of VMs that has been grouped in the virtual world rather than by the firewall itself. We call it SDN, software-defined networking, sometimes referred to as SDN by overlay, or at least our approach. And SDN by overlay means that instead of letting the virtual machines just push out whatever traffic they have right away into the physical network and have the physical network deal with this, we instead encapsulate on a hypervisor level on an encapsulation protocol. Currently, we are using VXLAN. It doesn't matter which protocol we are using, it's the behavior that I'm getting at right now. Meaning that I have a physical host, for instance, the one to the left in this picture. The virtualized host is running a number of VMs. I would like to make segments and separate these VMs. From a firewall perspective, this is already taken care of. But I would also like to create new VMs. Imagine that I have some kind of service where my customer can go in and click and they can order themselves from some kind of portal. And when they click on something, VMs should start and we can spin them up. The problem is now that if you do that in a legacy data center, every time you spin up a new VM that needs a new network, someone has to go down to the physical network and do some configuration in order to set the VLANs and the firewall rules and the routing and whatever is needed for this particular segment to be able to communicate and the VMs that is on this segment. But in this case, instead of letting the VM push the traffic to the physical network, we will let the hypervisor encapsulate that. So what the physical network sees is only the number of physical hosts that we have, not the VMs themselves, which means that we can create as many new segments as we want, and VXLAN allow us to create 16 million segments. If you compare that to VLAN, where we have 4,000 segments. So the cool thing now is that if you have a data center and you are creating virtual networks for your virtual machines, and you let the hypervisor encapsulate that when the virtual machines are communicating. This means that you lift off a lot of burden from the physical network. The most obvious is the creation of VLANs per segment, of course. But also, we have removed layer 2 stretching from the underlying physical network, the underlay, as we call it. The overlay is the virtual network, and we do very much use the physical network, of course, but only for transportation. So the thing is that if you are stretching your data center from the primary to the secondary, or from the primary to the disaster recovery, or from whatever data center you have and perhaps into the public cloud, that means that you need to do some kind of layer 2 stretching, which is kind of tricky. And the reason for this is that layer 2, as of today, is based on Ethernet. And at least in my mind, Ethernet is a crap protocol. Sorry. It wasn't designed for this. It was designed for a small environment. But it is the protocol that we use. And there are solutions in the physical network to stretch the layer 2. But they are either proprietary or very tricky. And I'm talking about MPLS, VPLS, EVPN, of course, spanning tree and stuff like that. But the thing is that, imagine that you take the SDN approach, the SDN by overlay approach, and you create networks for the VM in the VM environment instead. And you see the physical network as a pure transport network. That means that the physical network only needs to provide connectivity between IP addresses. So you can build the physical network now in layer 3 instead of providing some kind of layer 2 Ethernet stretching. And layer 3 has proven to be kind of stable, to say the least. It's been around on the internet for 30, 40, 50 years. And routing protocols such as OSPF and BGP could be used. They are highly tested, to say the least, and highly stable. And they provide redundancy and rerouting and optimization and all of that. So instead of doing proprietary layer 2 stretching with the SDN overlay and the networking in software, the underlying network becomes a pure transmission network. We need to have a gateway from physical external networks. This can be done by us from software component that we call Edge Gateway Service, or you can do it in hardware. And the same thing here applies. We have a number of certified partners that can do this in hardware. So meaning that they do bridging between the VLAN and a certain VXLAN. So taking traffic that's coming from an external network, placing it into the correct overlay network. So the end goal is this. We would like to be pool-based, not only for compute and storage, also for networking. So we create a VM. The VM sees its storage, the VM sees its network. The VM communicates over a number of firewall rules, but all of that is, in this type of approach, pure in software. Of course, there is physical host for the compute, there are physical disks somewhere for the storage, and of course there are physical routers and switches, but they do not have to deal with the individual property of individual VMs. So this is a tool for automation, for application continuity, and for security. Okay. If you would like to have, since you now have 2 networks, you do have 2 networks. You have one for pure traffic moving back and forth, and you have one that contains the intelligence and the functionality for the VMs. And in order to get visibility, I'll just mention that we have a tool that we call the vRealize Network Insight. And the vRealize Network Insight is a tool that can provide visibility into the virtual world, but also into the physical world. Because as we said, the physical network will not go away. The physical network needs to be there with high throughput, with low latency, with redundancy, and with 0 downtime, if possible. But the logical network we create in software. But with the Network Insight tool, we can see how much traffic we have on the overlay and on the underlay, and going back and forth from overlay and underlay. And in this view, we have percentage. In this view, we can monitor individual VLANs and segments and see how they communicate, and also what ports. So with this tool, you can do an assessment, and you can see what firewall rules do I need in my environment when you go from not having an NSX to having NSX in your data center. And this is also a really, really neat view. In this picture, we can see 2 VMs communicate with each other, one to the left, one to the right. We can see that they are passing a number of firewalls, a stateful firewall in the NSX. They are, in this example, passing a Palo Alto high-layer firewall. We can see that they are connected over a number of VXLAN, so this is how they communicate. But we also see down here, in the lowest part of the picture, what physical servers, not servers, routers and switches they are passing. So of course, the physical network will need to be there and well functioning, but the logics of the VM network is in software. If you run into trouble and you need to troubleshoot, of course, we have built in all the tools that you normally find in a switch and in a router. And with this tool, you can easily monitor, do I have problem in my virtual network or do I have problem in the physical network? And then you troubleshoot accordingly. The market seems to believe in us, VMware, and the NSX product. We have opened up a number of APIs for partners to come in and certify on NSX products. And here is a number of companies that we are communicating with and partnering up with, and they are certified in different aspects of the NSX product. Yeah, okay. 5 minutes, my last slide. If you want to try this, we have all our products and trainings online. So there is something called the hands-on labs. So if you go to hol.vmware.com, we have training for all our products, including a lab environment and lab documentation. So if you want to play around with NSX, go to hands-on labs, search for NSX, and there will be a number of classes that you can take, including free of charge, training documentation, and also lab environments. So it's really cool. Okay. Shahu, 5 minutes to go. Time for questions.
Right. Any questions from the audience?
So how does it compare your product to other products? Yeah. So how this product compares to other products in the market, and how it is different? Thank you.
I go back to my picture that I showed in the beginning. SDN is not meaning one single thing for everyone in the business. It's mean that you do something with software, right? And it's close to networking. So our product is built for a virtualized environment. And another company that is doing that is Juniper. They have a solution called Contrail. They're doing kind of the same thing that we do, but we target different audience, you may say. Juniper is more targeting towards telco and towards an OpenStack KVM environment, while we, at least for now, are mainly focusing on our product, the vSphere. If you have a company that does SDN in the underlay, using whatever technology for having white boxes and create their own software environment for routing and switching, that is something that is totally different. And from our perspective, we are agnostic to whatever underlay you have. So if you have something that you are happy with, regardless of what it is, can it push IP traffic, then we are happy. So it could be a SDN network, a hardware SDN network, or it could be whatever network. As long as it gives you whatever performance you need, then we are happy from an overlay perspective.
Anyone else? Otherwise, this was borderline rocket science for me, but I do have a question. You have the firewall solutions and the security solutions from all these partners on the side and all that. But what I wonder about is, or I seem to sense that somewhere inside the system there is the mother of all VMs. What protects her?
The mother of all VMs, you mean the hypervisor, or what do you mean? The hypervisor, yeah. The hypervisor, it's an operating system from us, and it's installed in the physical server. And as I said during the presentation, that is something that should not be reachable from anything within the virtual world, and it's protected, I would say, by the physical firewall, the perimeter firewall. So there should be a totally separated management network, and it is protected by either total isolation or by a perimeter firewall. It's up to whomever is building the data center.
Okay. Now is lunch, and I've forgotten one of my tasks. And if you see the other guys who came just ahead of you, this is a thank you. It also contains 2 invitations to today's after party, which one of which you can give to whomever asks you the best question.
Okay, I'll do that. I'll do that. Okay, cool.
So it's time for lunch now. If you can track down, who was ahead of you? Gentlemen, he's not here.
It was Microsoft, right?
Yeah, where is the Microsoft? They're everywhere, but anyway. Because I'll have to give him one of these bags as well. Maybe I'll take it downstairs and see if I can find him. So, okay, it is lunch. We have to be back here at 2 o'clock, 1400 hours. Keep in mind that it is a bit hard to get up here with the elevator, so I'll see you all back. Thank you for being here.